Hello, my students. How are you doing? My lovely students, today I'm going to review another subject. Please open your book, page 123. Subject Atmosphere and the Sun. Most of the sun's energy never reaches Earth, it is lost in space. Of the time fraction of the sun's energy that does reach Earth, about 3/10 is reflected out into space. Another 3/10 warms the air. The other 4/10 warms the land. My pupils, do you remember I write on the board 3/10 or 3/10 is reflect out into space. Other 3/10 warms the air, 4/10 warms the land and the oceans. 3/10 is reflect out into space. Other 3/10 warms the air. Other 4/10 warm the land and the oceans. Do you remember the definition of the greenhouse effect? The definition greenhouse effect very important, my pupils. Please try to pay attention to this subject. What is the greenhouse effect? The atmosphere traps this heat near Earth's surface, much like the glass of a greenhouse. Like the glass of a greenhouse. This process is called the greenhouse effect. Without this effect, Earth would reflect most of the sun's energy back into space, and Earth's surface would be too cold to support life. My people, do you remember this picture and imaginary sketch representing how Earth's atmosphere traps part of the sun's energy, much like the glass of a greenhouse. Energy from the sun. Greenhouse. Energy from the sun. From the sun. From the sun. Very important. Energy from the sun. Sun is trapped by gases in the air, causing the greenhouse effect. Sunlight passes through the atmosphere and warms Earth's surface. The greenhouse effect prevents most of the heat from escaping back into space and keeps it close to Earth's surface. Do you remember this question? How does the atmosphere work like a greenhouse? The answer of this question is that the atmosphere traps this heat near Earth's surface, much like the glass of a greenhouse. Please watch this video about greenhouse effect.
You've heard it 1,000 times, the greenhouse effect. But did you know the term is completely wrong when applied to the Earth's atmosphere? This idea of the atmosphere acting like a greenhouse is a false analogy that has helped fuel climate change hysteria. I know some of you will immediately accuse me of climate change heresy. Even so, hang with me for a moment. I assure you, no reputable scientist will disagree with the technical side of this explanation. Greenhouses work because they trap heat inside them. They prevent convection of air outside the greenhouse. The Earth's atmosphere works in the opposite way. There's no roof on the planet. The Earth's atmosphere is a nonlinear dynamic system that simultaneously absorbs and emits energy that it receives from the sun. The relative balance between energy gained and lost is what makes life on Earth possible. It's really quite amazing, and it's infinitely more complex than this dopey analogy of a greenhouse, which gives people explanation. Greenhouses work because they trap heat inside them. They prevent convection of air outside the greenhouse. The Earth's atmosphere works in the opposite way. There's no roof on the planet. The Earth's atmosphere is a nonlinear dynamic system that simultaneously absorbs and emits energy that it receives from the sun. The relative balance between energy gained and lost is what makes life on Earth possible. It's really quite amazing, and it's infinitely more complex than this dopey analogy of a greenhouse, which gives people the wrong impression of trapped heat. Climatologists are currently trying to figure out if man's burning of fossil fuels is substantially inhibiting the Earth's ability to emit excess energy. However, the addition of carbon dioxide and other gases to the atmosphere is but one small factor in an extraordinarily complex system. Here's something else many people don't know about our incredible planet. They have no idea that we live in a slender, habitable zone that is sandwiched between two very cold places. As any pilot can tell you, once a plane begins gaining altitude, the temperature outside drops shockingly fast. If it's 59 degrees on the ground, the air at just 7,500 feet is freezing. At 14,000 feet, it's only 9 degrees. By the time the plane hits a cruising altitude of 40,000 feet, the air temperature outside is 70 degrees. Impact 39 degrees. The cold, deep water of the oceans drops rapidly on descent. The average temperature of the oceans is a frigid 39 degrees. The cold, deep water of the oceans turns over at varying rates with warmer waters near the surface. It has a powerful impact on the Earth's climate. Slower or faster turnover in the Pacific Ocean creates the El Nino and La Nina effects that impact the entire planet's climate system. According to climatologists, the broader point is the Earth's atmosphere and oceans are dynamic systems that behave nothing like a greenhouse. The atmosphere is constantly emitting excess energy into the freezing air that's not all that far above us. And the oceans are continually transferring heat energy into the depths. These scientific truths are part of what led the UN's Intergovernmental Panel on Climate Change to report in 2001 that the climate system is a coupled, nonlinear, chaotic system, and therefore the long-term prediction. You've heard it 1,000 times, the greenhouse effect.